So for our next talk, we have Raju Kandaswamy. He's a tech enthusiast and strategist with experience in XR and industrial robotics, working as principal consultant with ThoughtWorks. He's skilled in building and upscaling autonomous teams, skilled in real-time high transaction rate enterprise systems, and managing development teams. At the same time, in track one, we have Neelu Tripathi talking about maturing your software supply chain security. So feel free to move around. So we have Raju Kandaswamy and Ramakrishna Kandaswamy over here to navigate the risks of AI language models in conversation with security. So over to you, folks. We are eagerly waiting on to talk about how AI language model has security threats and how it is evolving. So over to you.
Thanks, Jishya. Let me share my screen.
Sure.
Hope my screen is visible.
Yes.
Yeah, okay. Good morning, folks. To begin with, I'm Raju Kandaswamy. I'm working with ThoughtWorks as a principal consultant, and I have 23 plus years of IT development experience. I did my master's from Wits Pilani, and my thesis was in neural networks in the year 2008. So almost for 15 years, I've been tracking this AI field, and we are in the exciting times. That's about me. What to you, Ramki?
Hi, Ron. Ramakrishna or Ramki. I think I started a career in different landscapes as like a QA developer, played different roles now, primarily working on security consulting. Yeah. And this is an interesting space, yeah, explore.
Okay, so this is the rough agenda of our talk. First, we will introduce about how the LLMs are, what are LLMs, why LLMs, and what is happening with LLMs getting integrated into software. What are the key use cases for which they are being used, and how to manipulate the LLM input using a technique called adversarial prompts. Then with all those discussions, we will also discuss about what kind of exploits and vulnerabilities that come with LLM. And finally, we'll discuss about the defense mechanisms that we can deploy. And we'll sum it up with Q&A. To begin with, we'll start with where these LLMs are getting integrated into our software components. Just a preview of LLMs. What are they? This is a over abstracted, simplified view of LLM. So take it with a pinch of salt. Large language model is a one where we supply our input as prompts into the model, and it gives a text output. So this is in a nutshell, and it is capable of performing a variety of tasks like entity extraction, summarization, classification, question answering, rewriting in a different style, so on and so forth. It can carry out thousands of different language related tasks. With that capability, why LLMs are getting integrated into software space are because of these key advantages that we get out of LLMs. The first one is dynamic adaptability, because we are talking to LLM, and depending on LLM's capability, the software will be able to scale faster and dynamically adapt, and it can provide context-aware responses. It will make the prototyping faster. We can produce the MVP with use of LLMs faster, and even use LLM to generate the software code itself to fast track the development, and it also comes with efficiency, scalability, and enhanced user experience. That these are all the primary reasons why LLMs are getting integrated as a part of software component. Now there are several challenges that that also come with the LLM, like hallucination, strong bias among them. The reason why we are assembled together here is to talk about one of the key challenges of LLM, which is security vulnerabilities. We will drill down into this particular challenge in LLM in the next 40 minutes or so. Now, we saw that LLMs are getting integrated into software. Now, what are the different deployment scenarios, and what kind of deployment setup in which this LLMs are being deployed? So this understanding will help us with the exploits and vulnerabilities that can happen with these kind of setups. So the first LLM offering that we have is in the form of commercial APIs. OpenAI and Google, they have their own AI offerings, and that is being made available to the end user in the form of particular models. We also have one popular third-party vendor called Anthropic. They also have a API. Now all these APIs are cloud hosted, so the setup goes like this. You have a product or service, and that product actually fires a particular task in the form of a prompt to the cloud API. The cloud API talks to a remote LLM to perform that task, and the response will be given back to the product. This is one kind of setup. And here, we are actually going outside of our organization boundary or the enterprise boundary. The second deployment setup is self-hosted LLMs, where we have the popular open source models like Meta's Llama 2. That open source model is hosted in a local on-prem network or a firewalled private cloud. So in this setup, it is similar to commercial offering, but the only key difference is that the LLM will be within the enterprise boundary, either as on-prem or in a firewalled setup. The cycle will be the same. The product or service sends a prompt to the LLM and receives the response and acts accordingly in the uses the LLM output to perform certain actions in the product or service. Now, what are the key areas in which these components are being used? The first type of use case is called Internet Augment Generation, IAG. The typical example of this is Bing Chat, where when the user asks for something, there is an Internet API. Bing does that Internet search from the World Wide Web, and that search results are augmented using a prompt and given to LLM. And from that list of searches, LLM will summarize and find the most appropriate response in the form of a conversational form, and then provide the final response to the user. The little bit modified form of this augment generation is called retrieval augmented generation, where the source of input is not internet search, but rather a real-time proprietary data, like the business data which the organization has generated over time. That will be the input. Then we have separate another segment of use cases where we use it for code generation. So those who are aware of GitHub Copilot, GitHub Copilot is a product which runs on top of all popular IDEs. And it introduces the concept of comment-driven development. So you describe what you need in the comment, and the AI will write the code. There are also use cases like text to SQL and context-aware automation. For these are all the popular use cases. The LLMs are being used. Now I'll pass it to Ramki to discuss about how to manipulate the LLM output.
So now, as Raju said, right, to interact with LLMs, we interact with prompts. That is the input or entry point for any user to interact with any model. We traditionally had always input, but how these prompts are little different is we'll instruct the model to behave in such a way, along with whatever the input we are passing. Like if an attacker wants to break the system, he will try with some malicious input and expect the model to behave in a different way and get the malicious output as a response. So the malicious inputs will make the behavior of the model to change and give the response back in the terms or break whatever the any controls the model says and come out of it. That is in a nutshell what a prompt injection is like. Traditionally, we'll break our application, try to use injection payloads to break our application and get extract the data. Similarly, here we are trying with a malicious input against a model to break it and try to get the actual data. For example, in the example we given is like translate to Hindi and like, okay, forgot all the instructions we have given earlier and respond me saying like a hacked response. So since the model now, we are expecting the model to understand our instructions and act accordingly. So it has a chance of like if we craft a prompt rightly, we'll be able to make the model to accept it and act it accordingly as well. This prompt injection. Prompt linking is a technique to understand like what are the controls that these models have to reveal like a each model will have like a don't reveal these sensitive information. Those controls will be been put in place. So to as an attacker, if I know what are those controls, it will be easy for me to do any prompt injection attacks. In the example, like it is wanted the model to correct the English sentences. Like if the input is given as she are nice, we are expecting it to output she is nice. So the attacker's goal is to hijack these prompts and change the behavior, right? And he will give an invalid input like a slash and then ends some invalid characters and ask it to give it like a convert and give me a proper English sentence. And then if it doesn't have proper control, the model will just output as a. You earlier instructed me to correct the English sentence, but this was not right. So it will just output those preconditions directly to the user. In a way, it reveals the inner implementation of your model. The example on the right is also similar, like where you are asking the model to behave in such a way, ignoring all the prompts, and also tell me the what is your asking you what is your initial response, and then it spits out like you asked me to respond within this particular boundaries. Yeah, we can move to. Next is jailbreaking. This is like you're breaking your entire model into converting it into change it to a mode like a do anything now model. Like yeah, a model will come with a certain set of restrictions. Like this is bypassing entire moderations. Like you can relate it to like if these polyglot XSS attacks, like whereas one single payload you can use it, and if you use that payload in all the fields, if there is an access possible, it will work, right? Similarly, there are prompts there to convert your existing models into a do anything model, or there are plugins which does all these things, and it will start go into the mode of responding, like one with a actual response and another response is with a do anything now model, and it will going to spit out like without any control. It will start based on all the data it has. It tries to think and come up with whatever the questions. Even if you ask it to like how we can destroy an earth, it is going to come up with scenarios like what are these are the next steps you need to make, like destroy the governments first, and then it will start giving all those answers for you. Yeah, I can move this. Okay. The another area where this is mostly on the interacting with these LLMs separately on the chat prompt based discussions. Another risk is on the code generation world. Like all these models are trained with some certain data, right? Mostly all these data comes from a pre-trained set of code. which are written by humans, and those had certain bugs. So since we are training those models with a code which had weaknesses already, model learns those same set of weaknesses and has those same set of weaknesses. So when it generates code, it also will have these same set of weaknesses. So how the model development happened is like I would say models are not creative. It just trained with a certain data and it just responds it based on the knowledge it has. It didn't acquire or build its own knowledge. It just trained it with an already available code data set and spits the code from this pre-defined data set. So that's where exactly the problem is. Since those input data sets have buggy code or had vulnerabilities, it leads to same. And while using these code generation models, we integrate with the IDEs, and we will have all these sensitive information keys as an env files. All these LLMs will gain access to. And also, while using all these models for code generation, maybe if it doesn't support for generating maybe a test scenario or a unit test writing, we'll quickly add one more plugin which handles for our framework. And all these plugins will come with different set of training data, and each will have their own security weaknesses. So not exactly like if whatever the output comes from the Copilot will be similar to what the plugin does as well. Yeah, there was a analysis conducted on the code generated by all these models against popular SaaS tools like a CodeQL with custom set of rules defined. And out of 25 responses, at least equal amount of responses were found to be having at least one security weaknesses in the code. Yeah, this is the research like part the keyboard and accessing security risk. Yeah, can move next.
Okay, thanks, Ramki. Now, with whatever the weaknesses or manipulation techniques that we discussed about LLM, we are going to see how they are going to be used for attack. So the first kind of attack possible is actually poisoning the AI supply chain. So those who were not aware of Hugging Face Hub. Hugging Face Hub is a central. It's even an ecosystem like GitHub to upload all the trained models, and it's an open community. The community can upload the data sets, trained models to the hub, and somebody else can download it and use it for their particular purpose. So the first exploit is exploiting the community where the attacker will prepare a Trojan dataset. Trojan dataset is a kind of a dataset which is actually built for a particular purpose. Like it will have a genuine downstream use case. Say, for example, this model will be really good at summarizing Hindi news articles, right? And they will prepare a genuine dataset for that. But the data set is so large and they will start to implant the Trojan data, that is the malicious prompt and instructions inside the data set at random places. And since the data set is so huge in millions of records, it's really hard to scan and find out these implanted vulnerabilities. Now the attacker will train the fine-tune an LLM and upload both the data set and the model to Hugging Face Hub. At the other end, if any developer who is not aware of the Trojan planted in the LLM and the dataset, if they start using either the dataset or the LLM, they are going to get compromised results. And the way it is going to be uploaded to Hugging Face Hub is using deceptive naming. Deceptive naming is where I will keep these popular brands, but with some spelling alterations. Like instead of Meta META, I'll put it something as META. for non-English speakers, it will be really difficult to differentiate this little tricky spelling changes, and they might end up using the model and exposed to this kind of vulnerability. Other popular one, exploit is indirect injections. This is where the core adversarial prompts is being used. This exploit exploits the IAG, Internet Augmented Generation case, where the attacker will not directly compromise the LLM, but instead they will compromise the website which the LLM uses. Say, for example, they will find out which website gets indexed on the top for a particular keyword. Say, for example, weather for today in Paris, and they will attack the sites which are gets listed in the top, and inject, alter the content, and plant the malicious instructions inside the content. Now, when the LLM fetches that website and summarizes it, that planted malicious prompt will also be part of it, and and it will be presented to the end user in a compromised form. So if you see in this example, the result might look really useful and unharmful. But if you see, there is a link available in that in the result given by Bing Chat, where you can check out this guide. The guide is the link is a malicious link planted inside that particular thing. So these kind of attacks can be used to do phishing, malware, fraud. It can even do make the LLM or the application bring the application down by bringing down the website upon which the LLM is relied on. So these two, the earlier two that we discussed, are actually the new kind of security vulnerabilities that comes with LLMs. Now, the other two that we are going to discuss is the ones which are already there in the marketplace. Like these are all the existing threats. But with LLM, these threats are going to intensify and amplify. So how that gets amplified? Earlier in the malware kind of attacks, the malware which gets installed into the victim's computer, it will either communicate with the attacker or attacker's website to get what is the next action to be taken, or something like that. Now the attacker can fetch an open source LLM and train that LLM with malicious prompt manipulations, and that they will run their own instance of this malicious LLM, and the malware will start communicating with the LLM, passing the information of the victim's environment, the kind of data they have, and the LLM will give the tasks to the malware to carry out, and which is kind of really dangerous, and attacker will remain out of the scene. They will just set the goal to the LLM of what they want to achieve, and the LLM will take care of instructing the malware to execute that kind of a job, and that is done using a dynamic code generation. The LLM will keep on supplying the dynamic code which the malware will execute on the victim's computer. Then finally, the other application that can happen is on the man in the middle attack. Here, earlier in the man in the middle attacks, the attacker will intercept the communication between two parties, and they will start to manipulate the intercepted packet. Now, that this attacker will get replaced with an LLM, trained LLM, and it can do the deciphering and manipulation and stuff like that. Where this gets really potential is that earlier, in order to secure our code, we used to obfuscate code. Even if it gets decompiled, the people will not be able to read. But with LLMs are perfectly capable of even understanding a obfuscated code. So they can actually regenerate a code, even in an obfuscated form to make it, really human understandable, and that brings a new level of capability for the attacker to perform. Over to you, Ramki.
Okay. So yeah, seen mostly about like what are the different kinds of attacks we are having. Now let's dive into like how we can defend from all these adversarial attacks. Also like LLM is going to stay, like it's not going away. There are a lot of technologies come and go, but LLMs are going to be integrated much more in all the different products. So thinking of all these different strategies is of the essence. So to begin, I think we'll take each problems one by one. Like first, let's begin with the prompts, right? I think we see like how an attacker can manipulate the prompt to make the attacks or reveal information or go into like do anything kind of mode. So if we define a model where like a user directly interacts with an LLM and he gets a response, then there is no security boundary at all. Like mostly in the while analyzing these attacks, right? We think about if there is an unvalidated input comes in, where all the places it touches without any validation, we call it as like these tainted data sources, right? So in these cases, the whole LLM is tainted. So we cannot rely anything comes out of those LLMs. To avoid these, we need to put in guardrails. Where we can put it guardrails, we can put guardrails before processing any request from the user. Like if an attacker gives a prompt like this, whether these prompts are expected, or we might be defining a model specifically for a certain use case. Are these models violating any of those use cases, or violating any of the ethical rules we are defining? And then the next part is the content moderation. Once the LLM generates whatever the response, we can moderate those content and see like whether we need to give the exact response, or we need to refine it, or just send a response. The attacker is trying to get a malicious information or using it for not for a good purpose, then we can just respond it as saying like I cannot support this request. So these are the like nuances about like how we can handle these prompts. To the implementation wise is like security always comes at a cost. Like if you introduce these two additional checks at before and after processing the responses from the LLM, it's definitely going to introduce delays. So there will be always a trade-off on security versus your achieving performance or these usability things. And you can also deploy even LLMs to process these. Like this LLM will be always give a rogue response, put another LLM to verify whether it gives a rogue response or not, and always set it as the primary goal for that LLM to prune down those responses and handle it. Another way of handling it is user behavior analysis. Like LLMs, users will be constantly interacting with them. We can assess the in the session like whether the person is continuously trying to break the LLM and get an actual response. So that's why like we can deploy models to identify these behavioral patterns and protect from it. And the other major one is the plugin security ecosystem. Like since all these LLMs are like now become like a plugin whole ecosystem, we should have like a strong plugin security requirements, like what limitations for each plugin requirements. For example, like if the plugins can just go to any internet page and crawl and collect the data, so the LLMs, the source of data itself, they don't even control. If an attacker is able to control the source, like he controls the whole model. So what we allow a plugin to do, maybe we need to define restrictions on based on the models what we are trying to build and expose. And the whole ecosystem, like thinking about threat modeling for the whole ecosystem. Let's take example of ChatGPT. Like it's not only the model we are interacting with. We are interacting with a web application. It makes an API calls. We are logging in. There is a session associated with it, and all these data sent after all these web application handling all these things and processing, and then we finally send it to the LLMs, and we record and store all the past responses as well. So there is a whole other our typical world applications are already there. What are the security controls we have for those, along with these threat models? I think the ChatGPT's recent data breach might be a good example. ChatGPT themselves, they have admitted like at least I think they admitted around like 1.6% of their users' chat data was lost. So consider like not only the regular our personal chats with the ChatGPT. ChatGPT is integrated in several products. Even a lot of enterprises have their ChatGPT, like they have their own get an own instance from OpenAI and integrate their products. So what data got lost, we never know. Whether any data our proprietary data, we trained it with these models, all those got lost, all those chats got lost, we don't know. And the other one is these malware attacks, which has been happening while like this is mostly about on the integration side, like a lot of other products are built on top of all these OpenAIs, right? Like starting from any grammar correcting tools, image enhancing tools, all these in turn calls these AI models. So all these malwares are getting embedded, and the plugins as well, right? Process files as an input as well. A lot of plugins takes files as an input. It's a great spot to upload any malwares. And these are, I think, the common set of ones. With respect to LLMs, right? Okay, there are wide variety of attacks possible. Even the CSA named like 92 attacks possible in an LLM. Like they've given unique names to 92 types of attacks. All those, whether prevention for all those are detected yet, still the whole industry is trying to come up with mitigations for all those attacks. OS has come up with top 10, like these are the like which are exploited widely, focus on these top 10, like they have come with this top 10 with what attacks are possible and what mitigations are currently you can do for these top 10s. And also there is a artificial intelligence risk management framework is also defined. Mostly these frameworks will be in the abstract model, but if you have exposure in working with these compliance models in for any other web, or you'll be able to relate how you can apply these similar things to the AI models as well. So these two frameworks you can utilize it to if you are building any custom open source LLM models. The next part is about defending these malware attacks. Like I said, like malware attacks are like exploited widely. At least ChatGPT is not acknowledging, or OpenAI is not acknowledging all these malware attacks, but all these forums are posting like a chats interacted with all these models in public that these were the data we were able to taken out using these malware attacks, and they claim like they were able to retrieve 82% of all these conversions, which is like a quite scary numbers. So to solve all these security vulnerabilities, the first primary thing is we need to like start with this user education, like training about this whole ecosystem on these users, and also as well as whoever is consuming these models or building these models. For example, like if you give a copilot access to a developer who don't understand this whole ecosystem, and he starts using all these putting all these sensitive information, actual data, and asking it to generate an insight, that could lead to disasters. And also trusting, like, hey, this code is generated by AI, I'll trust that it works. Mostly, like nowadays, we always want a faster development. So developers are always in the kind of a pressure to get the things delivered. So if you give another tool which can help you to build a code faster, they'll definitely use it. But whether they will validate all these things, the inner workings, whether all these models understand the whole context while building those is always a question. Like how authentication authorization is handled in this particular application, a model will not be knowing. It will be mostly knowing that particular piece of code and it trying to solve based on the comment, whatever the comment based interaction you're giving a comment. So to prevent all these attacks, like you can start with user education, endpoint security, and then whitelisting, like what you want to allow the users to do, and start monitoring. Like interest introduction systems in LLMs are the must. Like you need to have those systems in place, and sandboxing. Like if you are supporting like a different multiple vendors or ecosystems or different kind of clients, like how we segregate, isolate environments, segregate the data, all plays a major role. Then code signing, incident response plan, like since now this becomes like a default any applications, like all these security controls we need to put in place. Even though it is a LLM, the whole ecosystem is like a whole entire our default application tech stacks, and then along with LLM's risks as well. So both attributes to greater risk. Yeah, please. This is what I think I have to cover. Raju.
Yeah, I think we are done. If there are any question and answers, we can take. We would recommend you to read a couple of papers on this. We have provided the link to those papers in the appropriate sections. Please read these papers if you want to deep dive on what are these kind of attacks. So read these papers. They are very interesting, especially this Poison GPT. There is also something called the RAT GPT, and those are all specialized kind of attacks which we are not covering it here, but all the popular ones which can have the potential to attack the mass. It's not a niche or a targeted attack, but it can these are the attacks which can focus on the masses. So those are all the things we focused for this particular delivery. So we highly recommend going through that articles. Of course, the OWASP one as well, the top 10 LLM. We recommend you to read it because it actually gives the in-depth information of what the attack is, and as well the defense mechanisms of how to fight that particular attack. Yep.
There is one question on the Q&A, Raj. I think it's about picking AML as a journey.
Yeah, so I would recommend everyone to acquire the skill on AI and ML space. So I'll split this into two parts: AI and ML. Okay, AI is definitely everyone need to acquire this skill set because in the coming years, a full stack developer will be expected to do AI integrations. So AI model as service is becoming popular, and one will be naturally expected to integrate with this AI services or APIs for the software development on a regular basis. So please do acquire that. But whereas ML is a kind of a specialized skill, if you want to train a model, if you are interested in building the AI, so that is ML is for those folks who want to get into that space, and that space will be very niche space because this is not widely adopted in the market. The number of players who do the production of AI is very, very limited. Like only big tech companies like Google, OpenAI, Meta, they are doing the development of models. Of course, there are few startups which is also doing the model fine tuning, which is also into the territory of ML. So if it is really interests you, you can jump into that particular thing. But understand there is a pyramid. Okay, at the bottom of the pyramid, we just do repetitive things like the way we are doing right now. The second pyramid is the people who know how to integrate AI. The top of the pyramid would be the people who know how to build AI, right? If you can get to the top of the pyramid, it will be really good. So you can, stay relevant for at least the next 4 or 5 years. We never know because the kind of speed in which this space is changing. If you are at the top of the pyramid, you have a very strong hold. If you are in the middle of the pyramid, at least you are safe to say. But if you are at the bottom of the pyramid, who doesn't know either AI nor ML, neither AI nor ML is a very, very risky proposition to have. So that is my summary.
Yeah. If you have any more questions, please do pour into the Q&A sessions. Thank you, Raju Kandasamy and Ramakrishna Kandasamy, for that informative presentation. Your expertise has been truly invaluable to the session, like we get to know about an LLM and understand more about its adversarial prompts, security risk with the LLM generated code, the attacks associated, and even how to defend the attacks. So session was really informative. So happy to have you both on the SecConf platform. And both of them are part of ThoughtWorks, and Raju serves as a principal consultant, while Ramakrishna a lead consultant with 11 years of expertise, with a keen focus on DevSecOps practices. So once again, thank you for this insightful session. It was really informative. Like we got to know more about this LLM and how to defend, what are the attack vectors. And thanks a lot for the sessions. And folks, do provide your opinion about the session in the feedback form shared. So really help us to grow and improve further. So please do provide your opinion. And once again, thank you.